Today, we are going to explore the properties of different 2D shapes, with a focus on triangles, which are three-sided shapes, and quadrilaterals, which are four-sided shapes. First, we're going to take a look at some important symbols. When we want to show that the sides of a shape are the same length, we use these little line markings. In my first triangle, all three sides have one little line mark, which shows that they are all the same length. In my second triangle, two sides have one little line mark, while one side has two little line marks. This is to show that the two sides with only one mark are equal in length, but they are different to the other side, which has more markings on it, to show that it is not the same as the rest of the lines in terms of their length. We also use special symbols to show where angles are the same size. In our rhombus, the bottom left and top right angles are equal in size. They're both acute angles. And we show this by using one arc in both of these angles. The top left and bottom right angles are the same length too, but these are obtuse. To show that they are the same as each other, but that they are different from the acute angles, we're going to do a double arc around these two angles. Let's now look at some triangles and learn how to classify them according to their angles and their sides. Let's begin by classifying them according to their angles. The first triangle has all three angles acute. This means we call it an acute angled triangle. The second one also has acute angles, but one of its angles is at 90 degrees. This means that it is a right-angled triangle. The last triangle has two acute angles, but because one of the angles is obtuse, we call this whole thing an obtuse angled triangle. Now let's classify them according to their sides. The first triangle has all three sides the same length. This means that it is an equilateral triangle. The second triangle has two sides the same length, which makes it isosceles. The last triangle has all three sides different lengths, which makes it a scalene triangle. Now, when we are asked to classify a triangle according to its angles and sides, we put these two words together. That means that the first triangle is an acute angled equilateral triangle. The second triangle is a right-angled isosceles triangle. And the last triangle is an obtuse angled scalene triangle. Pause the video and use the clues to classify these triangles according to their angles and sides. For our first triangle, we can see that it's got two acute angles, and although they are different in size, they are still both acute, but the third angle is at 90 degrees, so this makes it a right-angled triangle, and now we need to classify it according to its sides, so we're just going to write down the word right-angled for now. When I look at the sides, all three sides have different number of markings on them to show that they are all different lengths, so that means it's scalene. So altogether, I've got a right-angled scalene triangle. My second triangle has all three angles acute angles, so it would be an acute angled triangle, but now I need to look at the sides and I see that there is one marking on all three sides, which means that all three sides are the same length, making it an equilateral triangle. So altogether, it is an acute angled equilateral triangle. For our last one, we can see that, again, it's got two small acute angles, and here they are the same size, but it's also got an obtuse angle, so that makes this an obtuse angled triangle, but that's just according to its angles. When I look at its sides, I see that two sides are the same length because there is one marking on two sides of our triangle, while the third side of our triangle has two markings on it, meaning that it's different from the other two sides. This means that it's an isosceles triangle. Put it all together according to angles and sides. This is then an obtuse angled isosceles triangle. Take a look at these important words. Opposite means on the other side. So for example, I've got a square and the bottom left angle is opposite to the top right angle. And here we can see that they are the same size. They're both 90 degrees. If I had to have a look at the other two remaining angles, they are also opposite each other, so top left and bottom right. Adjacent means next to each other. So if I were to look at this rectangle, my left-hand side is next to the bottom of the rectangle. So we would say that the left is adjacent to the bottom. We've been given a set of properties. Let's prove that they match with the square. Firstly, I need to prove that opposite sides are equal in length. Well, I can see that in a square, the left-hand side is the same length as the right-hand side, and the top is the same length as the bottom. And because it is a square, I know that all of these measurements are going to be the same. So I'm only going to put one line marking on all of them. So this is true. Left is opposite from right and top is opposite from bottom. So the opposite sides are, in fact, equal in length. Adjacent sides are supposed to be equal in length as well. Well, the left-hand side is adjacent to the bottom is adjacent to the right-hand side is adjacent to the top is also adjacent to the left-hand side, and so we begin again. So all the sides next to each other are the same size. We can see that by our markings, so this property is true as well. Opposite sides are parallel. Let's see. The left-hand side of my square will never meet my right-hand side of my square, so they are parallel. The top of my square will never meet the bottom of my square, so they are also parallel. Opposite angles are the same, and in this case, they are 90 degrees. The bottom left and the top right of my square are both 90 degrees, and they are opposite each other. And the same can be said about the last two angles, which are also 90 degrees, and they are also opposite each other. So this is true. Now, do the same properties work with a rectangle? Well, I can see that opposite sides are equal in length. My left is equal to my right and my top is equal to my bottom. But with my left-hand side being adjacent to the bottom of my rectangle, I can see by these markings that they are not the same length. So that means that I need to have a look and explore what the properties of a rectangle actually are. Well, aside from the opposite sides being equal in length, I can also say that opposite sides are parallel, as the left-hand side and the right-hand side will never meet, and the top and the bottom will never meet either. The opposite angles are also the same. My bottom left angle is opposite to my top right angle, and they're both 90 degrees, and the same can be said for the last two opposite angles. Pause the video and draw in the properties of a rhombus and a parallelogram to show that they are true. In my rhombus, my left is opposite to my right and my top is opposite to my bottom. They are both equal in length. The left is adjacent to the bottom is adjacent to the right, and the right is adjacent to the top. They are all equal in length, so adjacent sides are also equal in length. Opposite sides are parallel because the left-hand side and the right-hand side will never meet. The top and the bottom will also never meet. Opposite angles need to be the same, and I can see that the acute angle on my bottom left is opposite the acute angle on my top right, and they are the same angle. Then the obtuse angle on my top left and the obtuse angle on my bottom right are also at the same angle, and they are also opposite each other. In a parallelogram, I can see that the left and the right opposite sides are equal in length, and the top and the bottom opposite sides are equal in length. My left-hand side and my right-hand side are parallel to each other. The top and the bottom are parallel to each other. My bottom left angle is opposite my top right angle, and they are the same size. And the same can be said for the other two angles, which are also opposite each other, and they are also the same size. Now to do the same for the trapezium and the kite, pause the video and try these two on your own. For the trapezium, I've got my top and my bottom lines, which will never meet, so they are parallel. Now, it says one pair of opposite sides are parallel, and the top and the bottom are opposite. And one pair means two, so two lines are parallel, and that is true. Then for the cut, I've got my top adjacent sides being equal in size and my bottom adjacent sides being equal in size. So this means that I've got two pairs of adjacent sides which are equal in length. And so this concludes our section on properties of triangles and quadrilaterals.